extras, but only extras for one thing. So
Yeah, I took one extra, that's why I'm asking if you missed this or not.
No, I'm not missing it.
Okay.
Monica,
Yes.
Leah is here. Can you let her into the Zoom meeting?
Yes, of course.
Thank you.
There she is. Okay. I'll leave that open in case more people show up. All right.
Oh, shoot.
Thank you. All right. So this lesson is on divisibility. Okay, divisibility by 2. All right. Good morning, children. You have been working very hard on your multiples and factoring work. And if you recall, when we looked at our multiples patterns table, we had seen some interesting patterns. We had noticed, for instance, that all the multiples of 2 were even, and we saw all sorts of patterns. Let me see if I can quickly find that for us and show it, just to remind us of what we did. Okay. So here's some of what we did, just a little bit. And there's reasons for these patterns, and we're going to sort of come up with some rules today. You're going to come up with some rules all on your own with the help of the materials that will explain why some of these patterns show up. So we're going to look at, this is called divisibility rules. And what word do you hear in there? What do you hear, divisibility? Right, division, right? Division, okay. So we're going to be looking at some patterns in what numbers can be divided, in this case by 2, without a remainder, okay? What numbers can be divided by 2 without a remainder? And the purpose for doing this is so that we can quickly recognize, once we know these rules, we can look at any number, no matter how large it is, and decide, is this divisible by 2 without a remainder or not? And this actually becomes a very important tool to have as you move forward in your math studies. All right, so we're going to begin. We are going to be using the stamp game today. You remember the stamp game from your lower elementary work. You used the stamp game quite a bit for learning your operations. So today we're going to be using it to show the divisibility by 2. All right, I'm going to start by making a number. My number is going to be, 1,126 to start with. 1,126. All right, so if you recall, the way we do division with the stamp game is we use our Skittles. In this case, we have 2 Skittles because we have 2 Skittles. I'm gonna put these up a little higher. You can't see them there. There we go. There you can see them. Okay. And we're using 2 Skittles, obviously, because we're dividing by 2. All right, so we're going to test whether 1,126 is in fact divisible by 2. So I am going to make my number 1,122. I'm sorry, 26. 3, 4, 5, 6. Okay. All right, and now we can start the division. Now, if you remember, in division, we always start with the greatest place value. So we're going to start with thousands. Obviously, I don't have enough thousands to evenly distribute among my divisor of 2. So I need to exchange this 1,000 for 10 hundredths. 2, 3, 4, 5, 6, 7, 8, 9. Okay, 10 hundredths. I'm going to put this back. Okay, so one thing I'll say about the stamp game, when you get to upper elementary, you're allowed to do that. This is sort of my rule. Upper elementary students are not going to put up with lining up all these hundreds in a nice even row. They're just not going to do it. So just accept the fact and go with it. Follow the child. All right. So now we can start distributing our hundreds. So I'm going to distribute in such a way that everybody has the same share, because that is how we do division. Okay, if you remember, the answer to a division problem is the share of 1. All right, so I have 100 left to distribute. Let me move this up a little bit so you can see the distribution better. There we go. I cannot distribute this 100 because that would give, wait a minute, am I right here? Hold on. Yes, okay. I cannot distribute this 100 because that will give 1 Skittle more than the other. So I need to exchange this for 10 tenths. 3, 4. Notice how I'm exchanging. This is note to teachers. I am not joining these 10s with the other 10s until I have confirmed that I have 10. Okay, so I keep them in my hand. I confirm that I have 10, that I've counted right. 6, let's see, 2. I think I did. 5, yeah, I did. Okay, and now I can place them all together. So there they are. And now I can start to continue my sharing. I'm actually going to move these up because I'm going to need the room. Oh, actually, no, I'm going to go sideways. Never mind. I'm good. Okay, so I'm going to start distributing the 10s. of course, equal shares. And here I do have to place them in order because I need to visually see that each skittle has the same amount of tens. All right, and it looks like I did it. Awesome. All right, I'm going to continue with the ones. Oops, sorry. Okay. There we go. Okay. So it looks like 1,126 is in fact, you know what, I again, another note to teacher. I just said 1,126. In Montessori, we always save the word and to use with decimals. So I actually said this number wrong. It should be 1,126. Don't put the and in there for those of you that are English speakers. We often do that. We'd like to save that and for when we get to decimals. All right, just a minor note. Okay, let's continue. So would you say that 1,126 is divisible by 2 without a remainder? Yes, it is. Wonderful. So I'm actually going to just put a check mark here. All right, that it is. All right, now I want to look at 1,127. 1,127. And I want to see if that, in fact, is divisible by 2. What do you think? Yeah, you're totally right. I'm going to add 1 unit. Therefore, I certainly don't have any way of sharing that 1 so that everybody has an equal share. So we can say that 1,127 does not divide equally by 2. Does not divide equally by 2. Okay, now let's try 1,128. 1,128 and see if that works. And do you think it does? Of course it does, because we can now distribute equally. So 1,128 works beautifully. What about 1,129? You said it, it does not. So at this point, the children really start to see the pattern. Usually you don't need to go further than this with the divisibility by 2 rule because it's so simple. And they've already seen it in the pattern of multiples, that the table of multiples of 2, all the numbers are even, okay? What they do need to see is that, in this case, how can you tell these numbers are even? This is kind of a new concept that they may not have seen. And that is that the last digit of the number tells you if it's even or odd. If the last digit is even, then the whole number is even. If the last digit is odd, the whole number is odd. So, but in my experience, children have been able to arrive at this rule, all by themselves, you know, in a very quick succession. All right. So now let me see if I think I put these rules on my computer. So let me just go back to my computer. Bear with me 1 second. And I'm going to put the rule up for you so you can see it. I'm going to share my screen. And I am on page 12. Let's just see where that is. Page. There we go. Divisibility, no, but Okay, so I'm just going to write the rule right here for you. The rule is a number that ends in 0, 2, 4, 6, or 8 is divisible by 2. Divisible by 2. I don't know why it's not letting me write any further. Divisible by 2. Come on. There we go. All right. So there is your rule. And of course, you would have the children, you don't give them the rule, right? Always. You have them arrive at the rule, and then you write it in the correct terms. They'll say it in their own words, and then you write it the way you want to define it, which is this way. All right, children, as a follow-up, I would like you to continue with this layout and just confirm the rule by doing some numbers. Actually, I would like you to start at 70, as I have written here. Go from 70 to 80 with the stamp game and confirm that this rule is correct. And go ahead and make a table in your notebook and just write whether the numbers that we did are divisible by 2 or are not divisible by 2, like I'm showing here. All right, and then please write the rule into your notebook. Okay, any questions?
Could you please scroll up again?
Yes.
Thank you.
Mm-hmm. There we go. Now you can see the whole thing. Okay, I'm actually going to take us, I'll post this also on Google Classroom under divisibility, so you have it, okay? All right, can I stop sharing screen? Everybody got their notes ready? Okay. Actually, now that I remember, there's another thing that Naomi asked me to review with you, and that is what I'll be looking for in your albums and in your notes. So let's use this as an example. In your notes, I would certainly expect that all lessons are titled. I would expect to see a drawing or a photo of the layout. I would expect to see any labels that were made, anything that was written down, also as part of your notes. All right. Hopefully, you will be able to catch some of the wording that I'm using to address the children. If you don't catch it the first time around, maybe you can go back and listen to the lesson again so that you do get some of that wording in there. Once you get your album, actually at the end of the course, what I do in my album is I highlight the quotes, because the quotes are really important. It tells you what the wording should be as you're presenting the materials. And, you know, the wording can either add to the understanding or add to the confusion. Oh, I see some people are trying to get in. So you want to make sure that you're using the correct wording. It doesn't have to be exactly what you see in the book or exactly what I do, but you have to find wording that you're comfortable with that will not take away, will actually add to the presentation. All right, so in your notes or your albums, when I'm checking them, I will be looking for pictures, notes on what we did, any labels, any definitions, etc. All right. Questions on that?
I just wanted to comment, Monica, it's Naomi. You can't see me, but I'm here in the background. I think what you said is really true. Whenever the students go back through and rewatch the videos, to really listen to the questions that you were asking the students and to make notes of it within their notes somewhere, because that's something that is important when they're teaching the students to, when they refresh the lesson before teaching, they're going to be like, aha, yes, this is what I'm supposed to ask the kids. And it will make the flow of the lesson go much better. So it's great now that they have access to the videos to rewatch them.
Yes, I agree.
And also the follow-up work for the children. So if you state that in your lessons, I think it's also important for the adult learners to write this down. Additional follow-up work that the students can do with each lesson.
And as you gain more experience, it will become more, you know, as we go through the lessons, you'll see the pattern. It'll become more intuitive to you what the follow-up should be. You can, as a rule, the follow-up is always to draw whatever layout we did together. And put that and write down any definitions, labels, etc. That is usually without fail what you do. And then after that, usually the follow-up is for them to go to the task cards and do, does everyone know what I mean by task cards? Task cards are basically, you know, just a set of cards that you'll have on a shelf, which gives the children more problems to practice. And they're usually organized sequentially, you know, according to how the lessons are presented. So you need to get Montessori task cards, not just any task cards, which will follow the progression of the lessons. And it just gives them more problems to practice with. And when we get to some of them squaring and square root and cubing and cube root lessons, I'm going to actually give you some problems to use for your practice so that you can be working with new numbers, but numbers that I know work. Okay, so task cards are really important. I did post links on Google Classroom for you to look at. Okay, all right. Our next presentation, we continue with divisibility, and we are going to do divisibility by 5. Divisibility by 5. So this is the order in which we do these divisibility rules. We start with the easiest and progress there. So first we do divisibility by 2, then we do divisibility by 5, then we do divisibility by 10. You could actually do divisibility by 10 before you do divisibility by 5, doesn't matter. Then you would do divisibility by 3. So let me write this down for you. The order would be 2, 5, 10, 3, 6, and 9. Okay, that would be the order in which you do them. And these are the only ones I recommend that you do. Your album will show you divisibility by 4. There are lessons out there for divisibility by 7, but the rules are so convoluted that the children will never come up with them. Eventually, you're just going to give them a list of all the rules. They're not going to derive the rules for some of the more complicated ones, because there's no point. You can do the material layout forever and they'll never see the pattern. So these are the ones I recommend that you do. And I will show you all the rules in a minute. You actually should have them in your handouts or in Google Classroom. Questions? All right. So we're going to now look at divisibility by 5.
We have a question here in the classroom, Monica.
Yes.
Go ahead.
It wasn't visible because of the black tape.
I'm sorry, I can't hear you.
Can you show one more time the sequence?
Yes, of course.
Here too.
Thank you.
Cool.
Yeah, I didn't see it.
Okay.
Now today we're only going to do 2 and 5 because you'll get the pattern. And then if you would like, you can practice with some of the others. Okay, can I move on? Are we good? Okay. Divisibility by 5. So we are going to start with the number 125. 125. And we are testing for divisibility by 5, so I need to get 5 Skittles for my divisor. That's a blue one, I don't want a blue one. Okay, there's my 5 Skittles. And now I am going to get 125 as my dividend. 100. 1, 2, 3, 4, 5. Okay, so I'm going to go ahead and start with the greatest place value. Of course, I cannot distribute the 100. I need to change the 100 over to 10. Let's exchange 3, 4, 5, 6, 7, 8, 9, 10. And now I can start my distribution. So I give each Skittle a 10. I see that I can continue, so I do. All right, I'm left with 2 10s. So I certainly cannot distribute those, so I'm going to need to exchange. I'm going to do one at a time, and I put the exchanging tiles in my hand before I join them. 3, 4, 5, 6, 7, 8, 9, 10. Make sure I have 10, and I do. And then I take my other 10 and I exchange again. 3, 4, 5, 6, 7, 8, 9, 10. I stress this because it is so frustrating for students if they make a mistake. So you really want this. This helps a lot, and this goes for all lessons. All right, so let's go ahead and start. This is a large distribution. I am not going to worry about whether my ones are straight or not, or whether they're right side up, because again, we're in upper elementary. I will never forget, there was a teacher in my school when I taught at Princeton who was she was a primary teacher, and rightly so, as a primary teacher, she was very, very conscious of developmental stages of her kids. And, you know, children that are in primary are in a sensitive period for order and quiet. And that's why if you've ever walked into a primary classroom, it's extremely orderly. It's pretty quiet. It's very different experience when you walk into an elementary classroom, right? Where there's, you know, lots and lots of movement. There's lots of interactions, right? In primary, children are doing mostly parallel work. There's not a lot of sort of joined work. That starts happening in elementary school. So she used to have occasion to come to our classroom. This was our lower elementary classroom, and she'd have to walk through. And she would always, her eyes would widen, and she would always comment on, my, oh my, it's loud in here. Or my, oh my, you know, things look really disordered. And she always, and we would always just roll our eyes like, yeah, there she goes again, Joyce. You know, she didn't really, coming from her point of view, we knew that our classroom was appropriately messy and appropriately loud compared to a primary classroom. Okay, little side story. All right, I have distributed my ones and I see that 125 is in fact divisible by 5. So I'll put a check mark next to 125. I'm going to now check 126. And it's very obvious that 126 does not work. Let's go ahead and see 127. And by now, the children are raising their hands, coming out of their seats, trying to tell you what they think. You're right. This will not be divisible by 5 until I get to 130. Until I get to 130. Okay. So let's go ahead and get there. And then we'll see that in fact, 130 is the first number after 125 that is divisible by 5. All right. And at this point, the children again will be raising their hands. Tell me, what do you think the rule is? You're right. The rule is that only numbers that end in 5 or 0 will be divisible by 5. And this just pops out at them, and it's amazing how easily they come to the rule. All right. So we go back to my computer and see if I have something set up for this. 16. Let me share my screen again. Any questions while I get there? Okay.
Monica, I have a question.
Yes.
You were talking about the task cards, and you said that you left a link on Google Classroom.
Yeah.
Would that be underneath the divisibility handouts? Is that correct? I just want to clarify.
No. It's on the stream.
Ah, okay.
Okay. All right. So I don't seem to have one for 5. I'm just going to create it. Divisibility by 5. All right. And what we looked at was 125. And we said that that was a yes. 126. And we said that that was a no. 127 was a no. 128 was a no. 129 was a no. And of course, 130 was the next number. And our rule is A number that ends in 0 or 5 is divisible by 5.
Can I ask a question, please?
Of course.
So do we do this using the stamp game in the same way for 10, 3, 6, and 9, and the children will just work through it?
So yeah, I would have the children do the 10 on their own. You could do, yeah, I mean, you could try it. I have always done them with the children. The list I showed you, I usually do them all with the children to make sure that they're on the right track. But if you have students that you think could maybe manage it on their own, certainly have them try. They can collect all the data, and maybe they won't see the rule right away. And maybe when they collect all the data and have everything laid out, they can come and show you. And then you can walk them through the analysis and try to help them come up with the rule. Okay, so you could do it either way. The way I've done it is I usually sit down with them and actually do the layouts with them, at least to start. But you'll have to judge your children and see how that works for you.
Thank you. And is this a 4th grade piece of work?
This is 4th grade. That was your question, yes?
Yes.
Okay, yeah, it's 4th grade. Okay, so that is where I'm going to stop presenting. I think that's pretty clear. Oh no, actually, I want to do one more presentation. I want to do the divisibility of 9. And, you know, I'm debating whether I want to do, there's a beautiful presentation. No, I'm not going to do it because I think it will be really hard to see. So I'm just going to do a different presentation for the rule of divisibility by 9. If we have time, maybe we'll come back to this. There's a beautiful presentation that you can do with the pegboard that's in the album. But for right now, I'm going to hold off on it because I'm just not convinced that it's going to translate well on video. All right, so, okay. Okay. So divisibility by 9. Let me just pull up. What page do we have? Page 124. Let's see if I can find it. Okay, don't seem to have it, so I'm going to just do some stuff here. All right, I'm going to put a page break here. All right. It's amazing. It doesn't matter how prepared I think I am. I always miss something, but that's fine. It's easy enough to fix. Divisibility by 9. Okay. So I would be doing this on the rug with the children or on a board. I could be doing it on a whiteboard with a small group. I think that might actually work better. Okay, so I'm going to put some numbers here. Let's see what we come up with. Give me a second, I don't have enough light. All right. All right. Okay, I think that's enough. All right, so. Okay, so children, I have some numbers here. We're going to today look at the rule, see if we can come up with a rule for divisibility of 9. All right, and I'm going to do something that you've probably never seen done before. I'm going to go ahead and add the value of the digits of 117. Okay, so that would be 1 plus 1 plus 7. And that equals to 9, of course. All right. Okay. And I'm going to now check whether 117 is evenly divisible by 9. I'm going to get my handy calculator here and divide 117 by 9. And lo and behold, it is 13. No remainder. Now let's look at 153. Let's add the digits again. 1 plus 5 plus 3 is equal to 9. If I divide 153 by 9, go back to my calculator, 153 divided by 9 is equal to 17, no remainder. Okay, let me add these digits up. 1 plus 2 plus 6, again, is equal to 9. And let me again check 126 divided by 9 is 14. All right, you get the idea. At this point, the children will be, again, raising their hands. So what do you think here? What do you think is going on? Yes, you're absolutely right. It's like a magic trick that if you add the digits of the numbers and you get a number equal to 9, then you can be sure that that number will be divisible by 9. Now, I want to take you back for a moment to what we came up with when we were looking at the factors of 9. The factors of 9, and you guys can go ahead and pull out your factor pattern sheet to look at this, but the factors of 9 went like this: 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and 99. Actually, this is a good one for me to show you. Okay, so if you add up the digits here is just 9, so of course that equals to 9. If you look at 18, 1 plus 8 equals 9. 27, 2 plus 7 equals 9. So on and so forth. Every sum of every one of these factors is equal to 9. And I think we actually might have noted this. I'm not sure, I don't remember, but I think we might have noted it as our pattern when we looked. We certainly noted that as the units went down by 1, the tens place value went up by 1, okay? Which is really another way of saying, because we're starting with 9 anyway, it's another way of saying that everything is going to add up to 9. All right, now I want to do 99 specifically because there's going to be times when you see this and I want you to be able to know what to do. If I take 99, I'm going to say 9 plus 9 is equal to 18. Well, I thought we said that it has to equal to 9 in order to be divisible by 9. When you end up with a sum like this that is 2 digits, you're not done. You need to continue adding the digits, just like you did before. And eventually you'll get to 9. Eventually you will get to 9. So my rule is, if the digits, if the sum of the digits of a number equals 9, the number is divisible by 9. There's my rule. Okay. As a follow-up, I will come back to this, and again, I will also post it so you'll have it. You can look back to it. As a follow-up, children, I would like you to take a look at this table right here. I have done the first example for you. Okay, and here's an example where I had to add twice. Oh, wait a minute, I didn't finish this. This should read, no, I'm sorry, I'm good. This is just showing that it is divisible. I did this you can use with a calculator. You can do this column with a calculator. And then here I confirm that the digits add up to 9. I would like you to finish this table, get a calculator, confirm that all these numbers are in fact divisible by 9, and then go ahead and confirm that the sum of the digits are equal to 9, just to reinforce the rule. All right, you don't need to copy this down, guys. I will post it so you'll have it. All right, but it gives you an idea here. Any questions? Okay. And then in your album, you're going to see there's some wonderful, wonderful presentations called Cast Out Nines. 9 is sort of a very magical number, and it allows you to do all sorts of interesting things. And really take the time to read this section. If we have time, I'm going to go through it with you because it's so wonderful. I'm sort of leaving some of these extra lessons that are, you know, kind of gravy until the end to see what we have time for. I want to make sure that I get through the critical lessons, but it's called Casting Out Nines, and you'll see it in your album when you get it, and they're wonderful. So you really want to look at those. Okay, once the children have finished all of their manipulative work and this divisibility work with 9, I then give them a table that shows them all of the rules. All right, and I'd like to go through them with you because they are very, very cool. Well, there's so much good stuff here for you guys. It's amazing. Divisibility handouts. Okay. So, rules of divisibility. All right, so this is a page that gives us the rules for pretty much anything they'll ever need. All right, so we already talked about the rule for 2. We talked about the rule for 5. The rule for 10 is very, very easy. A number is evenly divisible by 10. I don't like the use of this word evenly because of the confusion, possible confusion between even and odd numbers. So I would change that, you know, I would just say a number is divisible, okay? Because that's what divisibility means. It's divisible. If you want to stress that it's divisible without remainders, you can do that, but I wouldn't recommend using this evenly. Okay, a number is divisible by 10 if it ends in 0. All right, let's look at some of the rules that children will come up with on their own, namely 3 and 6. They may need some help, okay? A number is evenly divisible by 3 if the sum of the digits is divisible by 3. So here, if you, I would show this, I wouldn't show this with the stamp game necessarily. You know, maybe have children do it with the stamp game and see if they can come up with it. After they do the 9 rule, maybe they'll see it. Otherwise, they're really never going to get to it, right? But you could present this the same way that we presented divisibility by 9, just by showing a bunch of numbers, factors of 3, and showing that if you sum the digits and you get a number that is divisible by 3, when you sum the digits, then the whole number is divisible by 3. So for instance, 546 is 5 plus 4 plus 6, which equals 15. Not sure why it says 15 plus 3. I'm sorry, guys, this is wrong. This should be 1 plus 5 equals 6. I'm not sure why it says this. Never noticed that before. I've been using this forever. All right, so I will make a note.
But it's not plus.
Sorry?
Oh, sorry.
This should say 1 plus 5 equals 6.
But this is not plus. It says 15 divided by 3 equals 5.
Oh, thank you. Yes, you're right. Thank you. So really what they skipped is that you need to add 1 plus 5. Thank you for that. You need to add 1 plus 5 equals 6 in order to get to a number. Or you can just recognize that 15 is divisible by 3. That's why they do it this way. I'm sorry. Okay, so you either recognize or you keep going. 1 plus 5 is 6, and 6 is obviously divisible by 3. Thank you. Okay, the next one we would do is 6. And 6 is also kind of tricky, right? They can do this with the stamp game, you know, you'd have to try it. I usually do it with them. The rule is that it is divisible by 6 if it is both divisible by 2 and 3. So you actually have to do 2 tests here. On a number, you have to test whether it's divisible by 2. And then you have to test, if it's yes, if it is divisible by 2, you must test to see if it's divisible by 3. And only if it's divisible by both is it then divisible by 6. So you have to do 2 tests. If the first test comes out negative, you're done, okay? And we're gonna look at some examples of this, but they give you one here, 546. Okay, well, let's test divisibility by 2, which is the easiest one to do. It ends in an even number, therefore it is divisible by 2. And now let's test to see if it's divisible by 3. Let's do 4 plus 6 is 10, plus 5 is 15. 15 is divisible by 3. Therefore, 546 is divisible by 6. Okay, the rest, divisibility by 4. A number, and then you can see why I don't do this. They do it in the album they actually, in the album, just make a note, actually in the album, they suggest to do this with the golden beads. You can do that. I don't have golden beads in my classroom. Golden beads I view as strictly a primary material. So I just substituted the stamp game for it. All right. Okay, so the rule is for 4, a number is divisible by 4 if the last 2 digits are divisible by 4, or if the number ends with 2 zeros. Pretty obscure. I think that if you just have to give them the rule. All right, and the example they give is 1,296. You look at 96, and 96 divided by 4 is, of course, a whole number with no remainders. So there's nothing obvious here, right? You still have to use a calculator. It might be just as easy to put into the calculator 1296 divided by 4. If you have to figure out 96 divided by 4. So I'm not sure this rule is very useful, okay? I don't think it buys you very much. The same with 7. 7 is a convoluted mess. I'm not sure why we even have a rule. To see if a number is divisible by 7, here you go. Drop the units digit and subtract 2 times the units digit from the remaining number. Now, it's amazing that this works, right? That in itself is the beauty of math, right? Math is just one big puzzle. And you could do this. You continue to drop the units, multiply it by 2 and subtract it. And you reach a number that is small enough to know if it is evenly divisible by 7 or not. So you get to 28 or 21 or 14 or 35. Again, I'm not sure you're ever going to use this rule. I think it's just as easy to plug it into the calculator and figure out. But they're kind of fun. You could have children play with this. You know, if you give them some examples, let them do it, especially for those children that, you know, are into puzzles. All right, rule for 8. Again, if the last 3 digits are divisible by 8, then the whole number is. But again, you have to plug it into the calculator. I'm not sure what the value is. 11. If the difference of the sum of the digits in the odd numbered spaces and the sum of the digits in the even number spaces is 0 or 11. This is really interesting. Again, it's a pattern, right? It is a pattern. It's a puzzle in math. I always like to point out to children that, you know, we talk about whether math was invented or discovered. Was math invented or discovered? And we talk about what that means. And we talk about how math shows up everywhere in nature, right? We have the golden ratio, we have fractals, we have all sorts of examples that of mathematical concepts that show up in nature. And I do lessons on these things so that they can kind of see the wonder of math and, how it's a real phenomenon out there in the universe. So this is really kind of cool. This is a kind of cool pattern. And if you think about it, it makes a lot of sense. And finally, the rule for 12. A number is evenly divisible by 12 if it's divisible by both 3 and 4. So like the divisibility by 6, where you have to have 2 and 3, 3 and 4 has to be the rule for 12. And another thing to point out for 6 and 12 would be the greatest common factors. Okay, so is that what I want to say, or do I want to say the lowest common multiple? Probably either one, but certainly the lowest common multiple, right? The lowest common multiple for 3 and 4 is 12. So it makes sense that 12 has to be divisible by both those, or the number has to be divisible by both those. Likewise with 6, with 2 and 3, the greatest common factor. No, with 6, the greatest common factors are 2 and 3, or 3. The common factors are 2 and 3, all right? So if you think about all those relationships and discuss it with your children, because they're really quite remarkable. Questions on this? Okay, I put some, so these are some of the things that you will hand out to your children after they've seen all of the rules. This is a really cool thing. So what we have is we have numbers going down the first column here, just a random set of numbers. And then we have numbers across the rows. These are the divisors. So we want to check whether 36 is divisible by 2. You have the rules next to you, all right, or the rules in your head, and you check it and you write Y or N, yes or no. And then you keep checking 36. Is it divisible by 3? Yes, it is. Is it divisible by 4? No. Divisible by 5? No, etc., all the way to 12. Okay? So this would be a follow-up at the very end of divisibility for your children. By the way, I teach algebra in my middle school, and these are lessons that are given in the algebra textbooks, but of course without manipulatives. So it's really, again, a big help to students if you give them this experience. Questions? Any questions on divisibility? All right, I think we will take a 10-minute break. Let me ask you guys, do you want to break for a practice session at this point? Do you want to continue after our break? I'd like to hear from some of you. Well, let's see, raise your hand if you would like to continue with lessons after our break. Raise your hand. Let me just look at everybody because I can't see everybody right now. Okay, looks like a lot of people want to continue with lessons. All right, good. Okay, that's good. So, so we will go ahead, take a break until 1:30. For me, it's 8:30. For you, it is 2:30. Is that right? 3:30? I don't know. Not sure.
Yes.
Okay, so we'll come back at 1:30 and continue. Thank you very much.
Technical issues.
Monica,
Yes.
can you stop recording now? And then we can come back so that the file is not so large.
Yes, I can. Thank you. I will do that. Okay, recording has continued. All right, so this is the first of many squaring lessons. Don't know that we'll get through them all, but we'll try. So there are several things to think about. So these lessons are broken up into levels, level 1, 2, and 3. And I will actually post this list for you so you have it. I'm just going to talk about it right now, but don't worry about taking notes. I will post this. Let me just write that down on a piece of paper so I actually remember to do it. All right. So level 1 lessons, and I will, as we go through, I will identify the levels. Level 1 lessons, so those for 4th grade. A lot of the activities that we'll be doing, the aim for them is to continue memorizing their math facts if that's what they need. All right, so that's the primary aim for level 1. We're going to be working with the square of 10 a lot. So Naomi, just so you know, everyone's going to need their square of 10 and 3 rubber bands. So if you want to distribute those while I talk. So for level 1s, they also, the purpose of these lessons are to sort of analyze the square further in terms of thinking about what it means to square a number. They've been introduced to that in the powers of numbers lessons that we did yesterday. But they have a lot more analysis to do in that area. And so that's pretty much it for level 1. For level 2, for level 2 and 3, actually, I'm going to say that well, let's start with level 2. For level 2, the aim of these lessons are to introduce children to multiplying binomials times binomials.
Monica, will you please switch over your screen from the notes to the material?
I will show, bring it to the screen.
Mm-hmm. We're seeing the big screen as notes, and now we need to see the big screen as the material.
I haven't really started yet. I'm going to talk about the notes in a minute.
Okay, fine.
Right, but actually, no, you're right. I don't really need to do this. Let me stop sharing. Okay. Well, you see my cup of coffee there. Okay. So for level 2 and level 3, the aim of these lessons are to learn the patterns of the distributive property of multiplying a binomial times a binomial. So I'll just give you a quick example, just so you see. Right now I'm talking to you as teachers, I'm not talking to you as children. So, for instance, this problem right here, 3 plus 4 quantity squared, okay? Or, as you'll see for level 3s, it's going to become a plus b times quantity squared. So this is going to bring us back to Algebra 1. And those of you that loved Algebra 1 will love these lessons. Those of you that hated or didn't particularly like Algebra 1, you might learn to love it because things are going to come alive for you, maybe. I know my experience when I did my training, and again, being an engineer, I had a lot of math, but I was never given the connection between mathematics and geometry. I was given the rule. How do you do this? Well, a plus b squared equals a squared plus 2ab plus b squared. Everybody remembers that because it was drilled into our heads, okay? And children will see it again when they get to middle school and they get to algebra or pre-algebra. So we are giving them an opportunity to see this in a tactile fashion, all right? So this is really the objective for second and third level. Second level with numbers, third level with algebraic variables. We're actually going to do this without ever even introducing the idea of variables. Oh, somebody's trying to get in. Okay, so it's really a beautiful thing. Okay. All right, so let me now start. Okay. All right. So I'm going to just write the lesson name so we have it in front of us. That somebody, oh, thank you. All right. So the name of this lesson, and of course you had it in that screen share that I just did, and I lost my marker. Let me find my marker. All right. We'll write the name of the lesson again. It's the square of the binomial with the 10 square. Square of binomial with 10 square. Okay, hopefully you can see that. He's trying to talk and it's just echoing and we can't understand what you say. So if you're not talking to us, please mute. Otherwise,
Maybe it's
again, we have echoing. Are we okay? Any questions? Okay. So in this particular lesson, I would not put the title out before I start because the title won't mean anything to the children at this point. All right, so I'm giving this to you so you can have it in your notes, but I'm not going to show it to the students. Okay. Welcome, students. You have finished your divisibility work. Good job on that. We are now going to switch gears and we are going to study the squaring of numbers, And I want to start with a very familiar material. Okay, we have our 10 square. So who can tell me how many beads are in the 10 square? That's correct. There are 100 beads in the 10 square. And of course you could sit and count them, but you guys are beyond that, being in level 1 upper elementary. So we know that this square is a 10 by 10, a 10 by 10, which of course equals 100, equals 100. And you recall that another way to write this is 10 to the second power, or 10 squared. We remember that from our power lessons that we had, powers of numbers. Okay, so I am going to do something kind of fun here. I'm going to take my 10 square and I am going to break it up. And I'm going to show you how I'm going to do that. I'm going to take a rubber band and I'm going to put the rubber band right there, and I'm breaking up the 10 in this direction. Let me show you. I'm breaking up this 10 across here into two numbers. I'm breaking it up into 3 plus 7. 3 plus 7. So I'm going to write that down. Right. So I have 3 plus 7. Now you'll recall from previous lessons, by the way, these are lessons that I haven't shown you, but they're in your album, you'll see them. They're very easy. You'll recall from previous lessons, what do we call a number that's made up of two different numbers, or an expression, a mathematical number sentence, something that's made up of two numbers? We call that a binomial, a binomial. And if you recall, binomial, if we look at the, I believe it's the ancient Greek, maybe it's Latin, I'm not sure without looking at my notes, and I don't have them here. Bi means two, and nomial means name or item or number. So we have this thing here that is made up of two numbers. It's a binomial, made up of two numbers. Okay, but I'm not done fixing my my 10 bar here, or my 10 square. Because remember I said we're going to be looking at squaring numbers, yeah? So I'm going to turn this around this way. I'm going to take another rubber band. And now I'm going to, again, count 3 in, just like I did before. And I'm going to place my rubber band I have a question for you guys as teachers. I'm not talking to the students yet anymore. Did you see any of these presentations in lower elementary? Did you do any of this work?
No.
No, okay, good. All right, good. I see a lot of heads shaking no. That's good. I know that sometimes teachers will show some of this work in lower elementary if they have time because it's so beautiful. But good, I'm kind of glad you haven't seen it because it's kind of, there's some wow moments here that are really fun. All right, so now I have created, again, a binomial going in this direction. So I have a binomial we already talked about in this direction, 3 plus 7. And now I created the same binomial going in this direction, 3 plus 7. So what have I done? I have squared 3 plus 7, right? Because we said before when we had 10 by 10, it was 10 squared. Well, now we have, let me do it this way, we have 3 plus 7 multiplied by 3 plus 7. right? I have a square that's 3 plus 7 in this direction, 3 plus 7 in this direction. So just like when before we had the rubber bands, it was 10 by 10. Now it's 3 plus 7 times 3 plus 7. We have squared the binomial. So I'm actually going to write 3 plus 7 times 3 plus 7 . And I can write that in exponential notation as 3 plus 7 squared. Okay, again, this is a level 2 presentation. I will say if you have level 2s and level 3s that have not seen it, and if you have level 1s that are really advanced, you may include this. You may do it, with a mixed age group. You decide. But it's designed as a level 2, 5th grade lesson. All right, any questions before I continue? Everybody see how this is representing 3 plus 7 squared, the square of a binomial.
How would you please describe the concept you're teaching now?
Okay, your echo is really tough to listen to. How would I explain the concept to whom?
What is this actually teaching us? Sorry, guys, I'm sorry.
Okay, we haven't done anything yet. Okay, so it's a little early to ask that question. Just keep in mind what I said before about the squaring of the binomials. I hope you were here for that at the beginning, where I talked about this right here. This is the kind of thing we learned in algebra, okay? And we were taught that a plus b squared equals a squared plus 2ab plus b squared. We all memorized that, not really knowing why or what we were talking about, okay? Now we're gonna walk through some presentations with the children that will actually show them this geometrically. Okay, does that answer your question? Okay, any other questions? Are we all clear on how we've gotten this far? Because if you're not,
No, I'm sorry, I'm really not clear.
okay, can you articulate what you're not clear about? Or is it just a general confusion?
Yeah, I think it's a general confusion.
Okay, so I'm just going to run through it one more time.
Thank you.
Yeah.
Sorry, everyone.
No, that's really okay. Please, there's all sorts of levels of mathematical thinking that you guys walk into this classroom. So unfortunately, are you alone? You're not working with anybody. Who am I talking to? I can't read your name. I'm sorry.
It's Nola.
Oh, okay. So, I can certainly try and help you maybe after class, or you could call somebody that's also taking this class, maybe get on a Zoom call with them and maybe somebody can help you, but I will run through it again. So we have a 10 square, and we know that this is 10 multiplied by 10, right? Because we have 1 10 squared taken once, twice, 3, 4, 5, 6, 8, 10 times. So this represents 10 times 10, which equals 100, or it can be written as 10 squared. 10 in one direction, 10 in the other direction. The children know, they're very aware that multiplication is really working with squares and rectangles. So this is a very familiar concept to them. All right, so if we now break up the 10 on this side into 3 plus 7, simply by putting a rubber band, I've broken it up into now 3 plus 7. Okay, it's no longer 10, it is now 3 plus 7. Mm-hmm. Okay, so I'm then going to turn my square, get another rubber band, and I'm going to break this up now into 3 plus 7 as well. So I'm going to count over 3, and tighten my rubber band. make sure that I've got it. Hold on. Okay, come on, go over there. Thank you. All right. So now, what have I done? I've broken up this now into 3 plus 7, right? It's no longer 10. So I can look at this. Oh, excuse me, somebody's trying to get in. Oh, no. It's a reminder that tomorrow is tax day. I don't think so. Tax day was April 15th. Okay. So I have now broken up my 10 into 3 plus 7 in this direction. I've also broken up my 10 into 3 plus 7 in this direction. So now, instead of having 10 squared, I mean, I haven't changed the total number, right? It's still 100, but I've broken it into 3 plus 7 on this side times 3 plus 7 on this side. Just like 10 times 10, or 10 squared, I now have 3 plus 7 times 3 plus 7, or 3 plus 7 squared. Does that help a little bit?
Yeah, thank you.
Okay. All right, like I said, also please reach out. I'm sure there are plenty of people that would be willing to help you, and I certainly can stay with you after the lessons at the end of the day if you'd like, to look at it a little bit further. All right, any other questions? Yes.
I have one question for Czech speakers. I don't know how to translate a word squaring and binomial.
Binomial, okay.
Squaring je jakoby na druhou, ne?
Mocnina.
Mocnina.
I wonder why we're getting an echo. I wonder if it's me. I don't think it's me.
No, it's because Ruth is...
Guys, turn the volume down on your laptops. Sometimes that causes the echo. So
That's when there are two computers in one place.
I'm sorry?
That's when there are two computers in one room. That's why I have it sometimes when I unmute myself on the wrong computer. And that's why Ruth have it, because she is with Irina.
Okay, so Ruth and Irina are together. So it should work better if you guys would turn your volume down to like a lower level, and then there will not be such an echo.
Takže squaring je jako mocniny.
Squaring je asi mocniny a Bára našla, že to binomial je dvojčlen.
Ještě jednou, prosím.
Dvojčlen.
Jednou.
Dvojčlen.
Put it in the chat. Type it. What?
Slyšíš nás?
Jo, slyšela jsem dvojčlen, že je to.
Somebody want to check it here online?
To je jako používání mocnin, no, ten squaring.
Mocninování.
No.
Okay, are we a little bit clearer on what these words mean? Yay, thank you for asking. All right, so having done this, I want to now represent, what we've done is we've actually made 4 different shapes here, right? We have made this shape right here, which looks like it's a 3 by 3 square, right? 3 by 3 square. We made this shape here, which looks to be another square. This is a 7 by 7 square, 7 by 7 square. And then we made these 2 rectangles here and here. This rectangle looks to be 7 by 3. And this rectangle seems to be, again, 7 by 3 or 3 by 7, depending on how you look at it. And you students know that commutative property applies to multiplication. Remember all that work you did for the memorization of multiplication facts. Remember when we had all those duplicates and then we got rid of the duplicates because we said Well, 3 times 7 is the same as 7 times 3, so we don't need to memorize both of them. Remember how happy we were? We went down from like needing to know 100 math facts to 50. Everybody was all jumping around excited. So we've made 2 rectangles of 3 by 7 or 7 by 3. We've made 2 squares. One is a 3 by 3 square. One is a 7 by 7 square. And I think I want to just for this one time, I'm going to get the beads out, and we're going to go ahead and make these different shapes with our beads. And I want to do this just to reinforce what we're doing. So up in the corner here, we have our 3 by 3. And there I've made my 3 by 3. Okay. So now I'm gonna, let's do 7 3s over here. Actually, no, it doesn't matter, but I'm actually gonna do it this way. I'm going to build my rectangle here of 7 by 3. So I have 3 7 bars. 3 7 bars. Now I'm going to build my 7 by 7. I'm going to get my 7 7 bars. 1, 2, 3, 4, 5, 6, 7. So there is my 7 square. And then all that's left is my 7 3s. 2, 4, 6, 7. So I'm going to put them right here. All right, that's good. I'm not going to show this to you again because you kind of see it. I'm just doing it for this first time so that you can really see the pieces. 2, 4, 6, 7. So there are my 4 pieces. So let's go ahead and label these. Let's cut out. Oh, I have some labels here. This is nice. Okay, so this is 7 taken 3 times, right? 7 taken 3 times. And this, the other rectangle is 3 taken 7 times. 3 taken 7 times, which of course they are equal. And then I have my 3 squared, all right, and my 7 squared. Let me find my 3 squared. My 3 squared is right there. And my 7 squared is right there. Okay. I could also make really small labels just to make it even clearer. So let me just make some really small labels so that I can put them right on top of what we're doing. All right, so I'm going to say 3 times 7 is right there. I like that better. I know it's a little harder to see, but, and then I'm going to have 7 taken 3 times, and that's right there. 7 taken 3 times. And then 3 squared is right there. And finally, 7 squared is my large square right there. Okay, so what I have done is I have taken my 10 by 10, I've turned it into a binomial of 7 plus 3, I've squared that binomial, and I have made 4 shapes. I made 2 squares, one of 3 squared, one of 7 squared, and I've made 2 equivalent rectangles of 7 times 3 and 3 times 7. So if I were to add up all of these pieces, what do you think I'm going to get? Remember what we started with. We started with 100 beads. So if I add up all these pieces and I did my work correctly, I should get 100. All right, I should get 100. So let's see what we actually get. Okay, so here's my label. Actually, I just want to do this a little differently just to show you. So I'm going to take my 3 squared. I'm going to add it to 7 squared. I'm going to add that to 7 times 3. And I'm going to add that to 3 times 7. And if I add all those together, I should get 100. Can you see that, or is it off the? Okay, and here's another way of writing the very same thing. 3 squared plus 7 squared plus 7 times 3 plus 3 times 7. Okay. That equals 3 squared is equal to 9. 7 squared is equal to 49. 3 times 7 is 21. 7 times 3 is 21. And if I add those up, it's equal to 100. So that is a good check to tell me that I did this correctly. I'm going to share my screen with you again so you can see this all written out. And again, I will share these things on Google Classroom. Maybe I already have. All right, share screen, share, and there it is. 7 times 7, or 7 raised to the 2 power. I use the notation for 7 squared, since I'm working in just a Google document, I use the notation that you see on graphing calculators. It's typically understood that that little hat, that I don't know what that's called, represents an exponent. I mean, you can also raise that 2 as a superscript, but it's too complicated. So it slowed me down. So 7 times 7, or 7 raised to the 2 power, equals 49. That's our large square. 7 times 3 is 21. That's one of our rectangles. 3 times 7 is 21. That's the other rectangle. And the smallest square is the square.
What do we need to see now?
I'm sorry? Did somebody ask something?
What do we need to see now?
I'm just
showing the previous sharing of your screen.
Yeah, this is.
That's okay.
Yeah.
Okay.
This is what I've written on the mat here for the students, and I just wanted you to see it. Okay, and I will share this. It's actually, I put it into the summary of lessons for today, so you have it already. I think Naomi shared that with you, or I'm not sure, it's there. So every day I'm going to be putting up a summary of lessons. I'm posting it, and you guys will get all the notes that way, okay? In one place. All right, any questions on this before I move on? Okay. It's all perfectly clear? Okay, I hope so. All right, so the album shows this as a separate presentation, but I like to do it together. So children, as a follow-up to this lesson, I would like you to, first of all, copy this layout onto your notebook. I want you to draw the 10 square with the rubber bands. The title of the lesson is Squaring of a Binomial with the 10 square. So that will be your title, which you'll put right at the top of your layout. Don't forget your date. Remember, every work needs to have a title and a date. Without a title and a date, the lesson is out of context. We don't really know. If I'm showing your work to somebody, to your parents during conferences, they want to know what it is that you're doing. And if you don't title every lesson, if you don't date every lesson, then looking at a bunch of pictures and a bunch of numbers doesn't tell us anything. The title is what cues us into what the concept is. So please put your title in. I want you to draw the 10 square with the rubber bands. I want you to draw the 4 shapes that we made with the correct colored pencils. And I want you to write the equations showing that you get 100. In addition to that, another part of your follow-up is to graph the layout. So in your math notebook, you will make a graph where you will indicate the 7 by 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. You will note that rectangle and you will label it 7 times 3. You will do the same thing for the 3 squared. You will label that. You can color it in if you want or highlight it with the right colors. And then likewise with the 7 squared, I want you to show it as a 7 square, and then the other rectangle, the 3 by 7. And make sure you write 7 plus 3 on the top, 3 plus 7 on the bottom, because that is showing us that we're squaring a binomial.
Monica,
yes.
One of the students here asked about your checklist, and there's a lesson there that's called the product of a binomial and a monomial.
Yeah.
Are we not doing that one?
I am skipping that one because that's really a repeat of work that was done in lower elementary as part of the memorization work.
Okay, thank you for the clarification.
Yeah. Yeah, just so you know, guys, I am, having to really prioritize the lessons because, we just don't have the time. So just so you know, usually the way I run this course is I'm there for a whole week. I have full days. And a lot of the wonderful lessons that Naomi is showing you, I don't even do. I leave those up to the trainees to figure out because they're fairly straightforward from the album. I think that any of you could figure them out. It's wonderful to see them laid out for you and to have them. But I actually, in the course of this course, I do not do those lessons. I don't do integers. I don't do percentages. I don't do ratios. Instead, I do these lessons that I'm showing you. So obviously, I only have half the amount of time that I normally do, okay? So I'm having to really pare down what I show you, all right? And I'm trying to make it so that it's still clear. Any lessons that really build on other lessons, I make sure that I cover so that I don't confuse you. But please keep asking those questions. And if you're confused about something, it might cue me into the fact that, hey, I really forgot to introduce a previous concept, but I think I've got it covered. But you'll keep me on track, all right? All right, any other questions on this presentation? All right, students, this is your first follow-up. This I'd like you to do right now because it's all fresh in your mind. Over the next couple of weeks, I would like you to go to the task cards and find other binomials that you can do with the same materials and square them. So you might have a 6 plus 4 squared or 2 plus 8 squared. You might even see things like things like, well, no, actually, I'm not going to introduce that right now. Scratch that. So you're going to divide the square of 10 in all sorts of different ways and do the same kind of work. And that will probably take you about a week. All right. We will meet next week to take this concept further. Questions? All right. So I think that, let me just check the time. All right, so I want to check in with you right now. Do you want, the plan is we're going to continue working until 10, maybe 9:45. We'll take a maybe 20-minute break at that point. So my question to you right now, by a show of hands, do you want to continue until 9:45 with lessons, or do you want to have some practice time? So raise your hand if you would like lessons. Let me come closer to my computer. I don't see any hands up. Okay. Raise your hand if you would like practice time. A few hands. Prague, you don't care what you do. You guys are good either way, huh? All right, I do see quite a few hands for asking for practice time. So what I'm going to say is, Naomi, let me know if you think this is reasonable. Let's go ahead and practice and break and return at the turn of the hour. So for me, it would be 10. Does that work, Naomi?
Yes, I think that's fine for us. From what the students just said here, they're okay with practice or continuing. So yes, we can practice now if that works for you.
Okay, that's fine.
And practice and break.
Yeah. So
what time?
So we'll return at 10 o'clock my time, whatever it is your time. So it's you've got about 40 minutes. Okay.
Okay. So super. 4 o'clock. We'll be back here.
Okay, I will keep my sound on in case anybody has questions during practice time. If you're at Prague, you can certainly check with Naomi, but if you're on your own and you're trying to do something, those of you that don't have materials, go ahead and do it on graph paper like I showed you. Try 8 plus 2, 6 plus 4, and see if you can come up with all the equations. And I'll keep my my volume on, so I will hear you if you have a question. It might take me a minute or two to get back to you because I may not be in the room, but I will come back. Okay, so I'm here, I'm available to help you. All right. Okay, we'll see you at the turn of the hour. All right. Okay, square of the binomial with the 10th square using letters. Going to start with the same layout we did before, where we have our 10 square broken up into the binomial 3 plus 7, and we're squaring it. So we end up with 4 geometric shapes. We have 2 rectangles that are equal in size and value, 7 times 3 and 3 times 7. And we end up with 2 squares, which is 3 squared plus 7 squared in this case. All right. Okay, I am going to do a little trick here, guys. Of course, you remember these lessons from last year when you did them. But today we're going to take a step further into abstraction here, because you guys really get this. And here's what I'm going to do. I am going to let 7 be replaced with the letter A. I'm going to let 7 be replaced with the letter A. Okay, so this is a little peek for you, a little peek into algebra, all right? And I'm going to let the number 3 equal B. All right, so we're simply going to do the same work, but we're now going to substitute. Whenever we see the number 3, we're going to substitute it for the letter B. B will represent 3. And 7 will be represented by the letter A. And we'll talk about this at the end, why we're doing this, okay? For now, just go with me on this little journey. Okay, so having said that, instead of having 7 plus 3, I'm really going to have A plus B, where A is 7 and B is 3. Okay, so and I'm going to put that on the side here, because this side, I'm actually going to take these things and just put them aside a little bit. The side here is simply A plus B, or 7 plus 3. Okay, and then I'm going to replace this other side again with A plus B. I'm going to put it up here. Actually, I'm going to have to change this to read B plus A. 3 plus 7. Okay, we have 3 plus 7, or B plus A. So far, so good. Okay. All right, so 3 square is going to be replaced by B times B, which is B squared. B times B is B squared. Let me make this label a little smaller so it fits right on top of my square. Take my 3 square away. My big square, which was originally 7 squared, here's the original label, 7 square. Instead of being 7 by 7, it's going to be A times A, which is A squared. Okay, now I'm going to replace my 2 rectangles. So this was 3 times 7. This was 7 times 3. So I'm going to replace 7 times 3 by A times B. Because remember, A equals 7, B equals 3. So 7 times 3 gets replaced by A plus B. And 3 times 7 gets replaced by B times A. B times A, which is my second rectangle. And remember, commutative property of multiplication says that A times B is the same as B times A. It doesn't matter what values of A or B I put in there, and that's the whole point here, okay? I have now represented this with letters. If I take away this idea that A equals 7 and B equals 3, you can imagine that I could make A and B equal to anything I want. I can make A equal 2 and B equals 8. I could make A equal 1 and B equals 9. Any combination of numbers that gives me 10 would be properly represented, at least by the labels, not so much by the materials, but by the labels. Okay, so just as we did before, we're going to add all the pieces together. So let me just remove these labels. So I'm going to add A plus B to B plus A to B squared to A squared. And when I add those two together, those 4 together, I get this formula. Notice that it says, oh, by the way, when we do multiplication with letters instead of numbers, we don't use the multiplication sign, because imagine that would be very confusing if we had an X in here, right? The multiplication sign is an X. So usually we just write 2AB, which means 2 times A times B. And of course you can see the 2AB comes from A plus B, A times B plus B times A. So there's 2 of them. And commutative property, remember, tells me that AB equals BA, so it's 2AB. All right, so when you square a binomial where one number is A and the second number is B, this is the formula that gives you what that square is mathematically. It's A squared plus 2AB plus B squared. This is something that you are going to see again when you get to pre-algebra and to algebra. You're going to know this equation so well that you're going to dream about it, okay? All right, so let me show you now. I'm going to share my screen with you and just show you all this written on my screen so that you can see it more clearly. Let's see. Where is it? Don't seem to have it up. Let's see if I have it. Recent, page 163. Okay, I guess I didn't make it. I'll make it right now. Okay, so let me increase the font, make it bold. All right. So we're talking about squaring the binomial using letters. All right, so the 4 pieces are a squared plus b squared. Those are my two squares, plus a times b plus b times a. And I can certainly combine the AB plus the BA so that my final formula is A squared, I'm going to rearrange it just a little bit, plus 2AB plus B squared. Okay, children, the follow-up for this is to please copy the layout into your notebook. Make sure that you include that A equals 7 and B equals 3, and write all the equations down in your notebook. And that's really the only follow-up, guys. This is what's called an impressionistic lesson right now. You're just giving them an impression of something, and we'll be doing this again with somewhat more complicated problems, but this is all they need to do. There are no task cards, there's no real follow-up other than to copy the layout into their notebook. Questions? Okay. Put away my labels here and move on. Okay, so we have pretty much finished our work with squaring the binomial. We are now going to complicate things a little bit more, add a little bit more sophistication. The rest of the squaring lessons are strictly for level 3s or your very precocious level 2s if you have them. I had some this year. I actually had some level 3s in pre-algebra this year, which was kind of cool because they finished all the math Montessori lessons in 5th grade. So they started out with me in pre-algebra in middle school. They used to come into my classroom so excited. It was a set of 4 boys and they were just beside themselves with excitement. All right. Now we are going to look at a trinomial instead. Now, a trinomial, like a binomial, a trinomial has 3 numbers. So the name of this lesson is squaring a trinomial. Okay, squaring a trinomial using the 10 square. Okay. So now we're actually going to need more rubber bands. I think you need 4. Yeah, 4 rubber bands. Hopefully you have 4 and you all have a 10 square. All right. Squaring of a trinomial, and again, if we look at the etymology of the word, of course, tri, like in triangle, means 3, and nomial means name or number. All right, squaring the trinomial. All right, so I have my 100 square again. I'm going to, let's see, what do I want to do? I'm going to do 3, 5, and 2. Okay. 5 and 2. All right, I'm going to start by doing 3 plus 7 again, like we did before. 3 plus 7. So I take my 2 rubber bands and I put my 3 plus 7. Okay, so there's my 3 plus 7, 3 plus 7, my binomial from before. But I would like to make a trinomial this time, a trinomial. So I'm going to take another rubber band. So I have 3 along the bottom, and then I have 7. I want to get 3 plus 5 plus 2. 3 plus 5 plus 2. So I need to go right there. Let me tighten this up and then I'll show you what I have. So here I have, if you look at the bottom or the top, I've turned my 10 into a 3 plus 5 plus 2. 3 plus 5 plus 2. And because I want to square this trinomial, I'm going to do the same on the other side. I'm going to take my 7 and break it up into 5 plus 2. 5 plus 2. There it is. So I now have 3 plus 5 plus 2 times, it's this one, right? Times 3 plus 5 plus 2. Okay, so let me write that out. I have 3 plus 5 plus 2 times 3 plus 5 plus 2. Which of course I can rewrite as 3 plus 5 plus 2 squared. Here we go. 3 plus 5 plus 2 squared. All right, so you see that so far we've done the same thing, right, that we did before. It's just this time we've made more shapes, right, because we now have trinomials instead of binomials. So we've made, let's see what we've made here. So let's start by looking at the squares. So if you recall, when we were doing binomials, how many perfect squares did we end up with? Right, we ended up with 2 perfect squares. What do you think we're going to end up with here, since we're dealing with a trinomial? You're right, you're going to always end up with 3 perfect squares, 1 of each of the numbers. Okay, so let's see if we can find these squares. So here, right here at the top, we have our 2 square, 2 by 2. Right in the middle, we have our 5 square, 5 by 5. And right here at the bottom, we have our 3 square, 3 by 3. All right, so there's our 3 perfect squares. All right, let's see if we can find some other things. So when we were doing a binomial, we had 2 perfect squares and 2 equal rectangles, yeah? Okay, let's see what we get this time. We got our 3 perfect squares. So let's look at this rectangle down here. This rectangle is a 2 by 3. 2 by 3. This rectangle here is a 5 by 3, or 3 by 5, whichever way you want to look at it. This rectangle here is a 2 by 5. And this rectangle here is also a 2 by 5 or a 5 by 2. So we see these 2 rectangles are equal. We'll see this clearly when we go ahead and label them, but we have 2 equal rectangles. This was 3 by 5. Well, look what we have here. 3 by 5. So we have 2 equal rectangles. And then we have 3 by 2 or 2 by 3. Again, 2 equal rectangles. So we have made 3 perfect squares and 3 sets of equal rectangles. So let's break this up like we did before. Let's break this up and see what we have. Okay, let me just get some labels going. Okay, I'm going to identify my squares first. So I have my 3 square right there. 3 square. I have my 5 square right in the middle. 5 square right in the middle. And my 2 square, I'm going to use a smaller label for that. 2 square right here in the corner. All right. So there are my 3 squares. Okay. Now I'm going to identify my rectangles. Well, if I look right here, I have a 2 by 3. 2 by 3. I'm going to cut this back a little bit so it fits. There's my 2 by 3. All right, and what do I want to do next? Let's see, guys. Should we find the other rectangle that's like this one? Good idea. Okay, so how about right here? This is a 3 by 2. 3 by 2, or 2 by 3. Okay, I'm going to cut the label back so I can fit it on that little tiny rectangle. Okay. All right. Now, so we've got our 3 squares. We've got our first set of equal rectangles. What do we have here? We have a 5 by 3. A 5 by 3 right there. Good. And then we have the other, the 3 by 5 right over there. All right. Put that right there. And then all that's left is the last pair of rectangles. We have 2 by 5 and 5 by 2. 2 by 5. Cut that smaller. And 5 by 2. 2 by 5. And 5 by 2. All right. So here we go. All right, everything's labeled now. So just like before, all we need to do now is add all these pieces together, confirm that we get a value of 100, and then we know that we broke up the 100 square properly into a trinomial squared. Okay, so we're going to start with the 3 square and the 5 squared and the 2 squared. We're going to add those together. Then I'm going to have my 5 by 3 and my 3 by 5. Those are going to turn out to be 2 times 3 by 5 or 2 times 5 by 3 because of the commutative property of multiplication. Then we have my 2 times 3 and my 3 times 2. And finally my 5 times 2 and my 2 times 5. When I add all those together, you'll see that it equals 100. I'm going to move to the whiteboard to do all this arithmetic. which means for you guys, I'm going to share the screen. And hopefully I did this one. Okay, let me just find it, page 169. Okay, page 169, nope. There it is, okay. So, let me just write the title. What we're doing is squaring trinomial with the 10 square. Okay. So I've put all these pieces together. Okay, here is my first row, which is my 3 squared, 3 times 5 and 3 times 2. If I add those together, I get 9 plus 15 plus 6 equals 30. Then I have 5 times 3 and plus 5 times 5 plus 5 times 2. These should really say plus and not semicolon. Let me just fix that real quick. We're adding all these terms together. All right, when we add the second row, I get 50, right? 5 times 3 is 15, 5 times 5 is 25, plus 10 is 50. And finally, we have 2 times 3 plus 2 times 5 plus 2 squared is 6 plus 4 plus 10, giving me 20 for a total of 100. Okay, so I show it to you both in table form so you can see how it builds. And here's the whole equation. All right, this should really say, it says 10 squared, but what I really want to write, not as 10 squared, what I really want to write is 3 plus 5 plus 2 squared. And there are all the terms. And when you add them together, you get 100. Questions?
Show the picture with the square again.
I'm sorry, say that again.
Can you please show the picture again instead of the...
Yes. Yes. Okay.
Thank you.
You're welcome. All right, so this is where your graph paper will come in. We're going to actually graph this. So students, if you would get some graph paper, you can do it, or you can watch me do it. I'm going to just use one color for my graph. Since we're no longer working with the beads, you may use a different color if you'd like. So I'm going to start at the bottom. Is that the bottom left for you? Yeah, bottom left. So let me, okay. So I'm going to say 1, 2, 3. 1, 2, 3. There is my 2 times 3 rectangle right there. 2 times 3. Just going to place a label on it right now, just to be a little clearer. Can you see that? All right, and then I'm going to do my 5 times 3. 1, 2, 3, 4, 5 times 2 times 3 my 5 times 3. Okay, next I'm going to do my 3 square. 1, 2, 3, taken once, taken twice, taken 3 times. There's my perfect square of 3 squared. Here's my label, whether it is 3 square. Okay. That's my first row. I'm going to move up now to my second row where I have 2 taken 5 times. 1, 2 taken once, taken twice, taken 3 times, 4 times, 5 times.
Monica, can I ask a question, please?
Yes.
It's just about the order of how you write out the numbers. So, for example, on this graph paper, you have 2 times 3. So the 2 beads taken 3 times to represent 2 multiplied by 3, yeah?
Yes.
So I assume when you're doing this, it's good to be consistent with making sure that, for example, on the chart or table you just showed us,
right? Yes.
It can't be, for example, 3 times 5 if we've done on the little labels 5 times 3. Does that make sense?
Yes, absolutely. There may be inconsistencies in the way I'm presenting it.
That's fine.
Yes, and what it comes down to, that the students are so okay with the community property that they don't seem to care.
Okay, cool.
So, but you're totally right. Okay, thank you for pointing that out.
Okay, just wanted to check. Thank you.
Okay, so here's 2 taken 5 times. I hope everybody understood the question. What was being pointed out is that in row 1, I may be showing, instead of 3 times 2, I may be showing 2 times 3. It doesn't really matter, okay? You can try to be consistent with yourself, but again, the students aren't really worried so much about that because you are looking at each piece. And graphically, this is either 2 taken 3 times or it's 3 taken 2 times, okay? Graphically, it's the same. So they're not going to be too concerned about it. Okay, there is my 2 taken 5 times. Then I have my 5 square, which will be right there. Let me just make sure. 1, 2, 3, 4, 5, taken once, twice, 3, 4, 5, okay? There's my 5 square. And then I'm going to continue on the second row, and I have my 3 by 5. 1, 2, 3. Right there. 3 by 5. Let me actually put them on top. 2 times 3, 2 times 5, 3 times 5. And lastly, I have my 2 by 2 square up here. And then I have my 5 by 2 right here. And my 3 by 2 right there. Okay, children, your follow-up is to copy this whole layout with all the mathematical equations into your notebook. Make sure you label all these different pieces like I have. And after you've done that, I'd like you to graph it in your notebook and label all the different pieces. Of course, show me the addition of all the pieces to equal 100. When you're done with that, I would like you to go to the task cards on the shelf and do some other examples of trinomial square. You might have a 4 plus 1 plus 5 squared, or a 3 plus 3 plus 1 squared, all right? You have a choice of doing them either with the materials, or if you're comfortable enough, you can just go ahead and do it graphically. Make sure you label all of the squares and all of the rectangles, that you sum up all of the different pieces and show me that it equals to 100, showing every step, okay? I don't want to just see the answer. I want to see all your work, everything that you do. Questions? Okay. And we actually only have one more lesson in the squaring. It's 11:45 for me, so we have an hour and 15 minutes. So I think what we're going to do is we are going to do this last lesson, which will probably bring us to 11 o'clock for me, 5 o'clock for Prague. And then I'm going to let you take the rest of either, half hour to an hour, however long you want to practice. All right. So this next lesson will be the last lesson for today. So let's go ahead and show you that. It is very similar. I'm actually going to leave this right here. Any questions before I go on to the final lesson of the day? All right, we're going to now do, just like when we squared the binomial with numbers and then we did it with letters. We're going to do the same thing today. We're going to square our trinomial with letters. Okay, with letters. Squaring the trinomial with letters. I'm going to let A equal to 2, B equal to 5, and C equal to 3. A equals to 2, B equals to 5, C equals to 3. We are simply going to substitute. Let me put my labels back. 3 squared, 5 squared, 2 squared, 2 times 5, 2 times 3, 5 times 3, 3 times 5, 5 times 2, and 3 times 2. Okay. All right, let me just lay out some things here. So I said A is equal to 2, so A is going to be right there. So there's my 2. B is going to be right here next to the A. And then 3 is going to be C. 3 is going to be C. So I have A plus B plus C. Now let's identify them here so we can look at the square. A is 2. So this is A right here. B is 5, which is right there. And finally, C is 3, which is going to be right there, 3. Okay, so once again, I have A plus B plus C times A plus B plus C, or A plus B plus C squared. A plus B plus C squared, where we used to have 2 plus 5 plus 3 squared. So again, we have generalized this in order to come up with a general formula for squaring a trinomial, just like we came up with a regular general formula for squaring the binomial. Okay, so I'm going to take my 2 squared, I'm going to turn it over, and I'm going to write A squared, since A is equal to 2, and I'm going to place it right back. I'm going to do the same with my 5 squared. That's going to be B squared, because B is equal to 5. My 3 squared will be C squared, because C is equal to 3. So there are my 3 perfect squares. All right, I'm going to take my 5 times 3 rectangle, and I'm going to write B times C. B times C. And I'm going to take my similar rectangle of 2 times 5. And again, I'm going to write, I'm sorry, I want 3 times 5. Sorry. 3 times 5, I'm going to write B times C, or C times B, which is fine. C times B. C times B. Okay. Now let me go for my 2 times 3. 2 times 3 is going to be A times C. A times C. And my 3 times 2 will be C times A. C times A. All right, that takes care of my second set of rectangles, and I only have one set left, which is my 2 times 5 and 5 times 2. 2 times 5 is A times B. A times B. 5 times 2 is B times A. B times A. Okay, and now I am going to move to the whiteboard, and I'm going to add all these things together and see what happens. So let me get to my computer and share this with you. Okay, so we are squaring a trinomial with letters. We're letting A equal to 3. Oh, so this is, I'm sorry, these are a little different. So see, forgive me, but it should be okay. You understand that it doesn't, as long as you're consistent. If I was doing this with children, I would certainly, well, maybe we'll go ahead and change it. Let's go ahead and change it. Let me be consistent with what I said. I'm going to let 2 equals to A. B is 5 and C is 3. So see, when I did this yesterday, I just switched those around. Okay, So I'm going to be consistent. So my first row is going to be my first row, if I look at this, is going to be, I'm going to start at the top. Okay. So it's going to be a squared, starting at the top, a squared plus BA plus BA. I'm dropping the multiplication sign right now, plus CA. My second row will be AB plus B squared plus CB. And my third row will be my bottom row, AC plus BC plus C squared. Okay, so I'm gonna get rid of this. I don't really need it. All right, so now we're going to put everything together. I'm actually getting rid of this. D, I don't need it. All right, A plus B plus C squared is equal to, there are my three perfect squares, A squared plus B squared plus C squared. Okay, then I have my two AB rectangles, which come from, one is here, BA, and one is here, AB. 2AB plus my next set of rectangles are AC and CA. There's CA, there's AC, we have two of them, 2AC plus 2 times BC. So here's CB and here's BC. 9 terms, and I have 9 terms, so I know I've covered everything. So this turns out to be my new rule for squaring a trinomial. Okay, so if I were to give you a different trinomial, if I were to say 4 plus 2, I'm sorry, 4 plus 2 plus 4 squared, you should be able to go ahead and plug in those numbers, all right? It would be the same thing, okay? So this gives you a rule for discovering the value of squaring a trinomial, all right? No matter what the numbers are. Now in this case, you know it's always going to be 100 because I'm making everything equal to 10, but just like with the binomials, right? We did the binomials of we started with the 10 bar, but then we did binomials of the 10 square. Then we did binomials with the 8 square and the 7 square, remember? So the same thing here. I can make this anything I want. I can make this with a 4 plus 2 is 6 plus 1 is 7. I could do it with the 7 square and break it up into the square of a trinomial. All right, and once you have this formula, you don't have to go and do all this work with the layout to figure it out. You can just plug into this formula and, you know, you would assign values. So you would say, I don't know, A is equal to 4, B is equal to 2, C is equal to 1. And then you would plug in. A squared would be 1 squared, which is 1. Okay, I'm looking right here. Plus B squared is 4 because B is 2. Plus C squared, well, C squared, hold on, I did this wrong. This should be 4. So this should be 16. Okay, plus C squared is 1. plus. Okay, now I'm going to have 2 times AB. Well, what's AB? Is 8, so it's going to be 16. Plus 2 times AC. AC is 4, it's going to be 8. And 2 times BC. BC is 2, so it's going to be 4. So I know that the squaring, the squaring of this trinomial is 16 plus 4, which is 20. Plus 1 is 21. Well, let's just do 21. Plus 16 plus 4 is 20. Plus 8 is equal to 41 plus 8 is equal to 49, which in fact is 7 squared. Okay. By the way, when I said before that there'd be no follow-up for the squaring of the binomial with letters, I was wrong. This would be the follow-up. Go to the task cards, find different binomials. They may not necessarily equal to 10. Plug it into the formula that we discovered and show me all the math and then confirm that it's true, right? So I can say in this case, I know I'm right because 4 plus 2 plus 1 is 7, and I know that 7 squared is equal to 49. So that is my check that I did it correctly. Again, they're going to run into this formula in the second half of algebra when they start squaring trinomials algebraically, and certainly when they start factoring. So all this work really sets them up for that. Any questions on what I've done? All right. Let me stop sharing this. You have it in your, you should have all this already. Let me adjust my camera. So we are looking at a face instead of all right. So that's it for squaring. I didn't show you every presentation, but I showed you most of them, most of the key ones. So you should be in good shape with squaring. I encourage you to practice these. Tomorrow's schedule, we're going to start, I think we start square root. Yeah, so actually, there are a bunch more lessons in your album that you're going to get. It shows these next bunch of lessons as part of squaring. But in my original album, when I did my training, any lesson after this in this sequence is actually considered part of square root. So we will do that tomorrow. We'll start those lessons to prepare us to take a look at the inverse of squaring, which of course is taking the square root.
Monica?
Yes?
Does that mean that they're going to do the moving from one square to a non-square?
Yes. Yeah, we'll be doing moving from one square to a successive square, then one square to a non-successive square. And then after that, we'll get right into square root. And I will be, as soon as we're done here, I will be writing up the outline for tomorrow and sharing it with you guys on Google Classroom. I'll share it with you, Naomi, so you can have it. I'll make sure I put in all of the equations that we'll need and all the labels for all the lessons. I would like to get a little feedback from you today about the changes I made. I'd like a little feedback on the camera with the tripod, whether that seemed to work better, whether it worked going back and forth between my computer and the layouts and, you know, everything else that we talked about and changed. I'm hoping that this helped, especially those of you that are, that English is your second language. So maybe you'll give me some, you can give me some feedback now, or you can give me feedback in your journal. That, you know, either way is fine.
Would you like some verbal feedback now, Monica, or
I would love it, absolutely.
Well, for me, like you said, that it was good that you were switching between what you were presenting material-wise and also on your screen, so it was useful to see that. For me, this was quite intense work, but I think you were, trying to explain it to us as best you can, so I appreciate it.
Was the pace okay? You say it was intense. Was my pace okay?
No, it's fun. It was just the concept more and me trying to understand how I teach it to the kids.
Yeah. It's pretty, you're right. It's very intense. And this is the least of it when we get to square root. But I can't tell you, as intense as it feels, you know, I always say you don't really learn a lesson until you give it to children. And then once you give it to children once, it just seems that you've got it. And I want to say that for the children, these lessons are not, if you time it right, if you give it to children that are ready for the lessons, and that's part of what you'll, you know, the judgment that you will learn, right? To kind of see where your children are and what they're ready for. If you choose correctly, if you don't push children too fast, and if you give it to them when they're ready, these lessons are fabulous. And for them, they don't have the intensity that you feel, because we're coming with all our baggage about math and how we did it. And we're having to kind of translate everything we learned. And, you know, for some of us, it may even bring up, you know, anxiety from dealing with math through high school. And, you know, for some of us, it's really exciting because we love math. So there's going to be, as adults, we're going to have all these different reactions and emotions around this. Just be assured that it isn't intense for the children. If the children are confused, you back off and you judge. Say, you know what? Maybe Tony really wasn't ready for this lesson just yet. Let me step back and go over where I think his confusion might be. So the intensity is here for us because of our baggage and because we are seeing the lessons boom, 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 right? One after the other. And that is intense. So I hope that giving you enough breaks and going at the right pace will help smooth that out for you. Other feedback?
I think having this, the Tuesday lessons anticipated, involved, I guess, that was really helpful, so I can see what's coming next and just kind of visualize something in my hand and matching it with what you're doing. I just think that's very helpful for me.
Good, I'm glad.
I thought the tripod was, everything was very clear. Like it made the visual very clear and very easy to watch. So I think that worked out really well.
Good, I'm glad. Yeah, I didn't even know I owned a tripod until last night. I'm just stopping the recording. Forgive me.